Hello and welcome back to Calculus, the series where we explore integrals. First, I'd like to thank all the nice people that support this channel by liking and subscribing. Please recall, from the last video, we spoke about the basic rules of integration. Most important one being the power rule for integrals, and also we looked at how to integrate trigonometric functions. However, the examples we went over were extremely simple and what I call one-layer functions. Today, on the other hand, I would like to go over on how to integrate functions in the form of f of ax plus b, a supposed two-layer function, because technically this here is already a composite function, where inside of the function f we have another linear function ax plus b. So now let's begin by taking a look at a few formulas. Here we are integrating the function ax plus b raised to the power of n. This is a general expression. Based on the power rule, you already know the result is going to be ax plus b to the power of n plus 1, and then we have to divide by n plus 1. However, if you left your answer like this, it would be wrong, because inside we have another function, linear function, ax plus b, and we also have to divide by its derivative. When you evaluate the derivative of ax plus b, all you have is a. So now we also have to put a in the bottom. You might wonder, where exactly did this a come from? And that's not what I will show you right now. We already know that integrals and derivatives are completely opposite of each other. It means here we are doing the integral from left to right in one direction. So that means if we take the derivative of the right hand side, we will arrive at the left hand side. So let's do that. Since we're doing the derivative of this fraction, for now I will only take the top part, because the top part is the only place that has the variable x. On the bottom, a times n plus 1, it is simply a coefficient, and I will just multiply it later. So here, ax plus b to the power of n plus 1, when I do its derivative, according to the power rule, I would get n plus 1 times ax plus b to the power of n plus 1 minus 1, so just n. But this is not over, because we know a chain rule exists. That means we also have to multiply by the derivative of the inside. In this case, the derivative of ax plus b, which is simply a. Now that I have evaluated the derivative of the top part, I can then divide it by the coefficient which we had in the beginning, the a times n plus 1. And as you can see, the a's cancel out, top and bottom, and so do the n plus 1. So that means after doing the derivative of the entire right hand side, you will arrive at ax plus b to the power of n. And this right here was the function that we integrated originally. Perhaps now you can see why we also had to divide by the a when integrating this function. It's because when doing the derivative, we had to multiply by the derivative of the inside function ax plus b. So if you're doing an integral, which is the completely opposite action of derivative, now instead of multiplying that derivative, you have to divide it. Now, please note that the same thing works for trigonometric functions. If you have sine of ax plus b, then the integral you would get is going to be negative cosine of ax plus b, and then divided by a. The same thing applies for the cosine. Now please note one thing, it's extremely important. This formula only works when inside the parentheses or the inside function is linear. If you have something like f of ax squared plus bx plus c, for example, a quadratic function inside of f, and you evaluate the integral here, you cannot do the same thing. You cannot divide by ax squared plus bx plus c's derivative 2ax and plus b. It does not work the same. So please know the inside function must be linear. Okay, so now that you understand the theoretical part of this, let's take a look at two examples. For the first one, we're asked to evaluate the integral of 5 minus 2x to the power of negative 6. So first, immediately, according to the power rule, you already know that this is going to be 5 minus 2x to the power of negative 6 plus 1, which is negative 5. And then we also have to divide this thing by negative 5. But then you also know this is not it, because we also have to divide by another number here in the bottom. And that number would be the derivative of our inside function 5 minus 2x. In this case, the derivative is simply going to be negative 2. So that means our final answer can be simplified just a little bit, where on the bottom we have a 10, and on top we have 5 minus 2x to the power of negative 5. Of course, plus c. Next up, we have a trigonometric function that we have to integrate. That would be tan squared of 5x minus 1 dx. Here on the bottom, I wrote a little hint that says, first, use the Pythagorean identity to rewrite this function, because we do not know the integral of tan squared, and it is a complicated function. However, we do know that the integral of secant squared x is going to be tangent, so that is what I want to integrate. So step number 1 would be to rewrite this integral into secant squared of 5x minus 1 and minus 1. And then I rewrote it into two separate integrals for the sake of simplicity and clarity. From the first part of this integral, what you would get is that the result is going to be tangent of 5x minus 1. However, we also have to divide by the derivative of the inside, precisely the derivative of 5x minus 1, which is just 5. And then we have to subtract it by the integral of 1, which is simply going to be x. And finally, this is going to be our answer, the antiderivative function. So this is it for today. I hope this was useful to you. In the next video, we will take a look at how to evaluate definite integrals. So I definitely hope to see you there, and have a nice day. Bye.